Alright guys, here we are with chapter 19 notes. Again, make sure that you have a pencil and paper ready to go. You have a calculator. If not, go ahead and pause the video and grab that now. This particular chapter has a lot of stuff you need to write down, so make sure you have all that stuff available and ready to go. So first I want to talk about P versus P hat. P is the population's proportion. P hat is your sample proportion. So when we did chapter 18, we were dealing with P. We knew the population proportion. Now we do not. We call it P hat. If you remember, I think it was chapter 7, we had Y and Y hat. Y was your actual equation of your line. Y hat was what we estimated to be our equation of our line. So make sure you know the difference between P and P hat. If you use the wrong one on your test, they will absolutely dock you for it. So make sure you know the difference. Now we're talking about standard error and not standard deviation. The reason we are doing that is because we don't know the sample proportion. We're using an estimate, so we call it standard error instead. This allows us to estimate with a certain amount of room for error. So notice it is the same formula as it was for sample proportion. It just uses P hat and Q hat instead, and we call it standard error, not standard deviation. So first example, it says police set up an auto checkpoint at which drivers are stopped at their cars and inspected for safety problems. They find 14 out of 134 cars stopped have at least one safety violation. They want to estimate the percentage of all cars that may be unsafe. So our population in this particular one is all cars in the U.S. The sample size that we actually found were the 134 cars at the checkpoint. So P in this case would be the percent of all cars in the U.S. with at least one safety violation. It is impossible for us to check every single car in the U.S. That's why we get a sample. And so our P hat was our sample, which was 14 out of 134, or 10.4% cars had at least one safety violation. So it says based on the sample, we want to estimate the true percentage of cars that are unsafe. In our sample, it was the 10.4. We want to see what would it actually be if based on our population. So we're going to draw the normal model with 3 standard errors, not standard deviations. Our mean is still 10.4. We just got that from the problem. The standard error, you use the same formula we used in 18, but it is with P hat and Q hat instead, but they still work the exact same way. So when I put it, I have 10.4 as my mean, 2.6 for standard deviation. Now, it asks us to make a prediction about the true value of P within 95% confidence. Now, you remember a normal curve follows the 68, 95, 99.7 rule, which means 2 standard deviations away in either direction represents 95%. So that's these two values here, 5.2% and 15.6. So what we can say is, based on the sample, we are 95% confident that between 5.2% and 15.6% of all U.S. cars have a safety violation. So we're using this to estimate. We are 95% confident it's going to be between those two values. Now, I do want to make something very clear. This sentence at the bottom, please write it down. You have to write these sentences this way exactly. You're literally just going to plug in your numbers. So I want you to start off every single answer with, based on this sample, we are whatever percent, usually it's 95, but we will see others. We are 95% confident that between, fill in your two values of whatever your units is. In this case, it was U.S. cars with safety violations, but whatever the problem's talking about. So this is literally one of those fill-in-the-blank situations where I want you to memorize how to write this one sentence, because this one sentence is your answer. It's not like the answer is 5.2 to 15.6. Sometimes they'll ask you that, but really they want you to write this sentence out. So make sure you know how to do that. Okay, this is called a confidence interval. Like I said, we don't know the true proportion, so we use the sample proportion to get a confidence interval. So it is whatever your P hat is plus or minus the margin of error. Your margin of error says how off are we willing to be. So in our sample, we had, 10.7? 10.4, okay? So we had 10.4. So if I add my margin of error, I get to the upper limit. If I subtract the margin of error, I get my lower limit, and then we are between those two values. So it says the extent and the interval to either side of p hat is called your margin of error. As confidence level improves, please write these two sentences down. As confidence level improves, which means we go from 90% to 95% to 99% confident, the margin of error widens. That makes sense. The more confident you are, the more room you have for error. Okay, the other way it works is the margin of error tightens up, the confidence level will decrease. Okay, so just be careful about that. It says the balance between certainty and the precision is somewhat subjective, but we typically use a 90 or 95% confidence interval. I have absolutely seen them ask about others, and I'm pretty sure I provide worksheets with other confidence intervals, but 90 and 95 are the most popular. So make sure you know that the larger the sample size, the smaller the standard error, and therefore the smaller the margin of error. I'm telling you, this is one of those units where you just want to write everything on these PowerPoints down because it just has so much good information. Okay, you have the little cartoon. Feel free to pause the video and look at that. Next example says a consumer group hoping to estimate the percentage of college students who have cell phones surveyed 2,883 students as they entered a football stadium. 2,781 indicated they had a cell phone. Based on the sample, find a 95% confidence interval for the true proportion of any cell phone carrying college student. So, mind you, it is impossible to survey every single college student. So they took a sample of 2,883, and we're going to use that to predict the whole population. Okay, your mean is how you get this number. You had to do 2,781 divide 2,883, you get 96.5. Standard error is that square root of p hat q hat over n, and you get 0.34%. So we're going to fill in our normal bell curve. And if I want the margin of error, so this time it didn't ask for the confidence interval. I know my confidence interval is these two values between 95.82% and 97.18%, but it didn't ask for that. It asked for the margin of error. So for the margin of error, you actually take your mean and you subtract one of those values. It doesn't matter which one, it's the same number. The distance from 96.5% to 97.18% is the exact same as the distance from 96.5% to 95.82%. So it does not matter which one you do. They are the exact same. Just make sure when you list your margin of error, it's over here on the right at the very end. It says ME, that's margin of error, equals plus or minus 0.68%. You need the plus or minus because obviously your margin error goes in both directions. So don't forget the plus or minus. How we're going to do this in the calculator. So make sure you have your calculator with you. If not, like I said, pause and go get it. I need you to hit Stat. Go over to test. Now you're about to see a giant list of tests. I hate to break it to you, we're going to cover almost every single one of these by the end of this. Not today, but by the end of this unit. So you'll see Z-test, T-test, 2 sample T, 2 sample Z. Basically, you see a bunch of Z's and T's. In this unit, the next 5 chapters, we only do Z-test. I have not taught you what a T-test is. That comes in unit 6. Okay, so just scroll all the way down to letter A, where it says 1 proportion Z interval. Okay, doing 1 proportion Z interval is what that stands for. Click on it. X, your number of successes in this particular sample was 2,781. The sample size was 2,883, and we want a 95% confidence interval, so please hit calculate. Whoops, did not mean to do that. So on your calculator, you should have got your confidence interval was between 0.95788 and 0.97136. Make sure you have that. It also tells you your p hat value. So that's that middle number on your bell curve, and it repeats your sample size even though you already have it. If you want your margin of error in that confidence interval and that 2 numbers in the parentheses, you can subtract p hat from either one. It doesn't matter. It's literally in the middle, so it's going to be the same. Just make sure you put plus or minus with it. Now, here goes that fill in the blank sentence that I absolutely 100% need you to know how to do because you're going to write it a bajillion times. Based on the sample, we can be blank % confident. Like I said, this is usually 95, but I have seen others, so just be prepared for that. That the true proportion of, make sure you put your units in. This one is college students carrying cell phones. Whatever your units are, I don't care. Make sure you put them in, is between blank and blank. I have seen so many times students try and do this bottom sentence. Don't do it. It will be marked wrong. It says between blank and blank % of all college students carry cell phones. We can't do that because we're not 100% certain of that. We are just estimating that it is between this confidence interval, that it's going to be between blank and blank. So we have to go with the top one. Please make sure you write down how to write that sentence because you will have to write it over and over and over again. Oh, there's all the information. All right, don't forget conditions. These have not gone away. I told you in chapter 18 that you had to know the conditions because you will be writing them down. You have to test that it is independent and random. So it is independent because we know the values don't affect each other. We randomly sampled the college students as they entered the stadium. Population must be 10 times the sample size. So there was like 2,800 some students times 10. I'm sure there are more than 28,000 college students. 10 success and 10 failures. Again, we had to have more than 10 of each, 10 kids with cell phones and 10 kids without. I think we are good enough there. Here's how you calculate your margin of error. Oh, I'm sorry. Well, yeah, it is how you calculate margin of error, but it's also how you get other values. So here's your formula. Please write it down. You're going to need to use it. It says margin of error is your Z value, okay, times that standard error formula, square root of P hat Q hat over N. So if it needed you to work backwards, I've seen problems like this. Suppose a candidate is planning a poll and wants to estimate voter support within 3% with 95% confidence. How large of a sample does she need? So if she wants to be within 3%, that means she wants her margin of error to be 3% in either direction. She wants it to be 95% confident. The Z-score for 95% confident is 1.96. I'm going to show you how to calculate that on the next page. For now, just know it's 1.96. To estimate voter support. So in this situation, either they are going to vote for this person or not. So it's 50-50, but we don't know the sample size. So this is where a teensy bit of algebra comes in. You would have to divide the 1.96 over to the 0.03 side, square it, and then do the 0.5 times 0.5 divided by whatever that answer was over there to get in. If you're struggling with figuring that out, I have no problem like working it out so that you can see it, but it's just simple algebra. These are the popular values, okay? These are, we call them critical values. You see 90, 95, 98, 99. So this is where you say, I'm 98% confident the value falls between blank and blank. These are the biggest four I've seen. Like I said, 90 and 95 are by far the most popular, but I've seen the others. And let's just say you get one that is even less popular. It's not one of these four. Honestly, I just recommend memorizing these four so you don't have to do the math every single time one of these comes up. But if you need to find one by hand, you find the area under your bell curve for that value. So you would figure out where 90% is under that curve. You have to subtract one tail. Remember, when you find 95 percentile in that 68, 95, 99.7 rule, you're finding the middle 95%, which means there's 2.5% to the right and 2.5% to the left. 95 is in the middle. So you would subtract one of those tails. You only need to find one of them. And then you find that value on your Z table or using invalid norm in your calculator. Remember, you get to invalid norm by hitting second vars. So either one of those will get you that value if you run into one that's not one of these popular four critical values. All right, guys, those are chapter 19 notes. I'll post the classwork along with them. Hope you guys are doing well.